analyzing this a little bit more, another thing that I notice is everywhere here, the slope is 1. Well, that's when y and x are the same. And y divided by x, if they're the same guy, is 1. Everywhere here, my slopes seem to be negative 1. Well, that's on the line y equals negative x. So it'd be like, 5 comma negative 5, 10 comma negative 10, negative 2 comma 2. All of those, when you divide them, you get a negative 1. So that lines up well. Okay, let's look at E here. I go, okay, let's see, focus on flatness. Flat, 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 flat. That's flat when x equals 2. Another thing I notice is everything here vertically, nothing changes, so it must only be x's. So I'm going to try this one. Only x's. When you plug in 2, what do you get when you plug in 2? Everywhere when you plug in 2, the slope is 0. Well, when you do that, 2 minus 2, the slope is 0. Okay, so I like that for that one. Again, look for more details if you want to confirm it. Okay. This one here, all right. Very interesting. I kind of see, I'm going to try this with you guys. I see flat, 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 flat at x equals 0. Here it looks like it kind of falls off the page, but it is also flat all over here. But I don't want to say it's at 3. I want to say it's just a little bit further. I don't know. I'm going to go nuts here and call that at x's pi. And over here it looks like at negative pi, everything was 0. One notice. Next notice. Vertically, nothing is changing. So if nothing is changing vertically, it's only x's. Okay. So let's try dy dx equals, let's try sine of x. Okay. Now, only x's, check. Do this for me. You do sine of 0, anywhere where x is 0, sine of 0 is 0. Anywhere where x is pi, sine of pi is 0. Anywhere where x is negative pi, it's 0. That fits. The next thing I want you to notice is this. If you pick a point, say I pick there, and I go and I follow the trend, and I follow the trend, and I could pick another one, and I could try it here, and I can go, okay, it goes up, flat, up, flat. You could argue that looks like a parabola. I'm going to argue it looks like a trig guy because it's a parabola for a little bit, but then it starts to bend back down later on all of them. It flattens out at negative pi and pi. So another way to look is, let's do this guy where I find the specific or general path that a train could follow. Remember, I would want you to move the dx over, and then I could integrate. And the integral of 1 dy is y. The integral of sine x is not cosine x. It's negative cosine x plus c. Do those two paths that I showed you, the green guy and the black guy, does it look like a cosine guy but flipped upside down? Remember, cosine normally starts up high and bends down. Here's normal cosine. That's normal cosine, but it doesn't do that. It starts lower and then goes up. Well, that's what the negative does. It just flips it. Okay. Looking at this one, hopefully now you see this trend. Flat, 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 flat. That is somewhere between -1 and -2. And between 1 and 2 here, it's flat, 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 flat. So let's just say this is when x is, I don't know, pi over 2. X is, I don't know, negative pi over 2. Okay. Vertically, nothing changes, so it's only in terms of x. So let's try dy dx equals cosine x. Okay. Cosine of pi over 2, 0. Cosine of negative pi over 2, 0. And now let's take a look at these paths. I'm going to look at one something like this. Up, flat, up. Now, what path is that red guy? To me, it feels like sine x, but it's upside down. I feel like it's actually negative sine x. Now, I know my prediction currently is cosine x is my slope field generator, but watch what happens if I do this. dy equals cosine x dx. When I integrate, I get y equals sine x plus c. I don't feel like I fit it correctly. I think I'm off by a negative and a negative, and then the integral of negative cosine happens to be negative sine x. Now, what messes students up all of the time is this. You are looking at two different worlds at once. This is so important because on the AP test, they're going to give you a multiple choice question, and it's going to say which of these 4 slope fields fits this equation. Or here's one slope field, here's 4 equations, which one fits it? Here's where students get messed up. The red that I drew on this board, the red is the D world, and this is y equals negative sine x. That's plus c. That is the D world. That is a railroad path. It's the actual track that could be laid out. I could have it up above. I could have it a little bit higher, or a little bit higher, or a little bit lower. All of those are the red, and that's the D world. When I ask you what is the slope field, though, the slope field is the V world. It is not the red answer. The red answer is when you integrate up out of the slope field and get the actual path. So the slope field in this case is this guy. You don't see cosine x on the board at all. You just see lots of little tick marks that were created from that negative cosine x. The guy that's easier to see is the D because it's really quick to lay out a path. But the question is not saying what is the path, it's saying what created the slope field, and that's the dy dx is negative cosine x. That is so important to remember. Okay, let's take a look at one like this. Now this guy, H, there's a lot going on in H, okay? It seems to be flat, 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 and then it starts to ramp up. Like any path that I chose here, boom, boom, boom. Or if I choose one down low, it still boom, ramps up, okay? Now, one thing to notice is vertically, everything is the same. Vertically, everything the same. I'm curious though, name a guy where almost everything on the left over there is basically 0. And the one guy that fits that is the dy dx equals e to the x minus 2. Anytime you plug in a negative number, so if you plug in a negative number, plug in negatives, you'd be getting like e to the negative 2 minus 2, which is e to the negative 4, which is 1 over e to the 4. 1 over e to the 4 is really small. That's not how you spell small. Oh well. E to the negative 1 minus 2 is e to the negative 3, which is 1 over e cubed. Again, really small number. Likewise, if you choose something over here, do you see how the slopes are ramping up pretty quick? Because look, if I do e to the 5 minus 2, I get e to the third. That's a lot. If I do e to the 4 minus 2, I get e to the second. That's a lot. So on the left, you get a lot of small. On the right, you get a lot of big. That's that style. Okay. Let me just lay out the other ones for you guys. Let's see. Let me get them just laid out for you because it's taken up a lot of time. Where you guys are at right now, this would have been the last one I would have found because that ln of absolute value is just funky. Okay. One thing to note is ln of 1 is 0, and that's flat. And ln of -1 is undefined, but when it's an absolute value, you get ln of 1, which is still 0. And on this one, the big thing to notice is everything here is 0, and everything here is 0. The only way that occurs is when x equals 0 or y equals 0. So those are those. Okay. Some bookwork problems that you might see is something like this. This is question 2 in the book, and it says basically, why is that? And that thing there is that. Do they work or not? I want you to think of this as the D, and this is what creates the slope field. Now you might go, it doesn't look like what we've been doing all day, but if I could somehow get this to be like dy dx equals stuff, then it would be, which is pretty easy because I can move this and say dy dx is negative e to the negative 2x minus 5y all over 3. That is y prime, which is your dy dx. So that is your slope field. This is the guy that would create all of the ticks. And the red there would be a path that goes through those ticks. Now this question does not ask for giving the ticks and drawing the graph. It doesn't say give me the actual path on those graphs. Nothing visual here. It's just saying show me that that red path would fit into that slope field. That's what it's saying. So the way you can check it is to say, all right, if that's y, then y prime would be stamp address. So I have y and I have y prime. Let's take both of those guys and throw it into here, and let's see if it satisfies the slope field formula. So I'd have 3 y primes. Now y prime is negative 2 e to the negative 2x plus 5 y's. Now who's my y? Well, that's up here as e to the negative 2x. Is supposed to equal negative e to the negative 2x. Let's see if it works. This would be negative 6e to the negative 2x plus 5e to the negative 2x. I hope equals negative e to the negative 2x. Negative 6 plus negative 6 plus 5 is the negative e to the negative 2x. Since these agree, it means it's a match. What that means visually, you do not need to do all the work, but what it means visually is if I have tick marks, tick, 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 whatever the tick marks are, and I give you the path, y equals negative 2e to the negative 2x, that red path would go through those tick marks. That's all it means, is the red path fits the blue tick marks. Okay? Another one that you might see is this on 36. Lays out all sorts of things, and it's again trying to say, do you agree or not? The path is the D world, and it's trying to tell you that those paths should fit these slope fields. So the blue creates the slope field, and then the yellow would be a path that pierces through that slope field. Well, let's check it. Best way to check it is to try and take this derivative. I'm going to just rewrite it here for a second. Now notice, we're going to take this derivative in terms of x, but it's not y equals right now. So you have to remember, this is that implicit style. So when I take this derivative, I'm going to get 6x plus 4y y prime. Remember, anytime you touch a y, it's a y prime, equals, well, the derivative of c is 0. Now, I hope my path's derivative fits the slope field. It almost does. I wish I could, let's say, multiply by a half, and I would get 3x plus 2y y prime equals 0. Aha! Perfect fit. So I know the path does fit the slope field. So all of those ticks that slope field could create, and if you don't see those ticks, could I write it this way and say y prime is negative 3x over 2y. That's your slope field. You could produce all sorts of ticks with that. And if I could somehow find the path, I would have 3x squared plus 2y squared equals c. And now it tells me, hey, you're going through a specific town. So I don't have a plus c anymore. I need to know exactly what that plus c is. You can take that and plug in. I'm going to do that way down here. Sorry, there's lots of arrows in this problem. I could do 3 times 1 plus 2 times 3. Oops, sorry. Plugged in the wrong one. 3 times 1 squared plus 2 times 3 squared needs to equal that c. So I got 3 plus 9, 18 equals that c. C has to be 21. So if c is 21, then my path would be 3x squared plus 2y squared equals 21. And now that path fits the slope field, and it goes through the specific town 1, 3. So from that, here's your first homework assignment. Let's see, our videos were 20 minutes, and about another 20 minutes. That's 60 minutes. You had some time to work on your own on setting up some slope fields and tick marks. So that might have spent 15, 20 minutes doing that. So you might have a little bit of time left to work on this. Tomorrow's video lecture, we will go over this homework a little bit, and you'll dive into the next part of the notes. The next day, Tuesday's notes. Again, I am gone because I have had a baby, and I don't know if that baby's a boy or a girl yet, because it's weird. You're listening to this now, but I'm recording it in the past. It's like the Twilight Zone. Woo, woo, woo. Hope you have a good day, guys. We'll see you later this week.